Our properties of logarithms, there's three basic ones that we're going to use. The first one is when you have a product. So it says log base b of x times y. If you have a product, you can split the log, log base b of x plus log base b of y. If there were three things, you would have three different logs. The next one would be a quotient or division. If you have a quotient, you're going to go log base b of the numerator minus log base b of the denominator. And it's really important that anything that was in the denominator gets a negative in front of the log. And finally, the last one is when you have an exponent or a power, you can move the power to the front. So you times the power to the front of the log. So it's n times log base b of x. So let's go ahead and expand. This first example for part A says log base 2 of 3x. I want to think of that as 3 times x. It's a product, so you're going to use the first property. So we'll go log base 2 of 3 plus log base 2 of x. And that's it. There's your expanded expression. If there were three items, we would have three different logs. Over here, you have log base 5 of y divided by 3z. So we can think of this as the numerator and denominator. So log base 5 of y minus log base 5 of 3z. And then you can go further over here because now you have a product. So that gets split up, but it's really important that you understand that the negative is in front. So let's drop this down. And again, the negative is in front, so it's log base 5 of 3. And then these get split with log base 5 of z with a plus, but the negative gets distributed to both logs. So from the top you have log base 5 of y, the y is on top and that log is positive. The 3 and the z are in the denominator and both of their logs have a negative in front. Log base 5 of 3, log base 5 of z, they both have negatives. So we have log of 4 plus log of a squared, and there's two things, so you split with a plus and they're being multiplied, so that's why you're using a plus. And then finally the 2 is an exponent, so you can move the exponent to the front. So it's going to be log of 4 plus 2 log of a. So that's the expanded form. On this problem right here, it says square root, so we'll rewrite that as a 1/2. So we have ln natural log of 3x to the 1/2. And we can move this exponent to the front, so we get 1/2 ln of 3x. And then we can actually split this up. So it's 1/2 and it's ln of 3 plus ln of x. This was a product, so we split with a plus. And then you're going to distribute the 1/2 to both natural logs. Now we're going to condense. We're going in the other direction. You have log base 3 of 16 minus log base 3 of 8. The minus means you're going to use division, and we're going to go 16 goes to the top, 8 on the bottom. And again, the 8 goes to the bottom because that was the log that had the negative. So, and then anytime you can simplify further, go ahead and do so. So we get log base 3 of 2. So we condensed to a single log. Okay, right here we're going to do the same thing. We're going to go log of 5 over the 15. And the base number is 10, so you don't have to write anything. Again, the log with the 5 was positive, so the 5 went to the top. The log with the 15 had a negative in front, so that's why the 15 went to the denominator. And then we're going to simplify to get 1/3. Now, we could leave it like that, totally fine, but if this was multiple choice, just be aware that this could be the answer, or, now that I look at it, it could be split back up to log of 1 minus log of 3, which is kind of strange. And the whole point of this was because there's implied base 10, so 10 to the what power is 1. Again, 10 to the what exponent is 1, and you get 0. So this could also be an answer. Part C, you have 3 different logs. We're going to condense to a single log. First thing I want to do is move this to the exponent. So you get log base 5 of x squared. And then I'm going to drop these down, plus log base 5 of 3 minus log base 5 of 9. So we have 3 logs, and the quickest way to do this that helps make sense is any log that has a positive in front, that thing goes to the numerator. So this one's a positive, so its 3 goes to the numerator, so you get 3x squared. And then any log with a negative, its value goes to the denominator, and then you get log base 5 reduce x squared over 3. So there's your condensed to 1 log. Okay, part D, we're going to use kind of that shortcut. Right here you just have log of a. The 3 will go into the exponent. So that would be b cubed. And then I'm going to drop these logs down. Okay, so we have 4 logs. We're going to write it as just 1 log and a fraction. This log is positive, so the a goes to the numerator. This log is positive, so the b cubed also goes to the numerator. This log is negative, so the c goes to the denominator. This log's negative, so d goes to the denominator. And there's your condensed to a single log. Okay, we're moving on to equations. This example says solve the exponential equation. It's an exponential equation because your variables are in the exponent. So what we're going to do in this problem is we want the same bases. So if you notice, you have 9 and 27. These problems are super rigged. So you're thinking about what base number they can both be written as. So we're going to use 3. 3 squared is 9. But don't forget the 9 still had a 2x on it. 27 would be 3 cubed. And that value still had the x minus 1 as the exponent. So now we're going to use properties of exponents. When you have an exponent to exponents, you multiply. So you get 4x. Over here you have exponents to exponents. You're going to multiply, but be really careful. You have to distribute. So you get 3x minus 3. And then now you have a statement where the base numbers are the same. So you can use the logic that therefore the exponents must be equal to each other. So we're going to write 4x equals 3x minus 3. And then you can solve this nice linear equation. We'll subtract 3x over, which just gives you x equals negative 3. Continuing with a similar problem, we have another exponential equation, again because the variables are in the exponent. And we want to make both of these base numbers the same number. So I'm thinking 2. So this 1/2, you can rewrite it as 2 to the negative 1. You still have x minus 3 in that exponent. And then the 4 can be written as 2 squared. You still have x up here. So now you have base numbers, exponents to exponents. Go ahead and multiply those exponents, but distribute. Over here, exponent to exponent, multiply, you get 2x. And then again, we're using the logic that they have the same bases. It's an equation. They're equal to each other, so you can conclude that the exponents must be equal to each other. We have a nice linear equation to finish solving. So let's go ahead and add this x over, making 3x equals 3. So x equals 1. This equation is 4 to the x minus 6 equals 3. So it's going to be we're going to use a different process than we just did, but like any normal equation, the first thing is wherever the term with the variable is, you want to isolate it. So let's first add 6. So you get 4 to the x equals 9. All right, so when we get to this point, you can see we can't use the process we just did because these numbers, you can't write them as the same base number. This would be 2 squared. That would be 3 squared. So you can't use that process we just used. So instead, what we're going to do is we are going to take the log of both sides. And specifically, what you do is you identify the variable and you look at its base. Its base number is 4. So we're going to go log base 4 of both sides. And when you take the log base 4 of both sides, so you can see 4 to the x and the 9 didn't change, you just take the log base 4 of both sides. What happens is on this side, these undo each other, and you're just left with the exponent, which is x. So here's your answer, log base 4 of 9. You can leave it like that, or you could use the change of base formula if you wanted to from before. This example, 5 plus 2 times 10 to the x equals 125. Again, like a normal equation, let's subtract 5. And like a normal equation, let's divide out that 2. All right, so we get to here, we have 10 to the x equals 60. And again, because it's an exponential equation and you can't write these as the same base, we're going to have to use a different process. We're going to take the log of both sides. Here's the variable, the base is 10, so when we go log base 10, remember you don't have to write the 10 because it's implied. And log base 10, those undo each other, and you're just left with the exponent, which happens to just be x, so x equals log of 60. Here's one more exponential equation. Again, like a normal equation, we'll divide out the 4, so you get 5. All right, so at this point, we have e to the 2x equals 5. We need to solve for the variable, because this is an exponential equation. So we're going to take the log of both sides, but it's specifically going to be log base e. And again, you don't write log base e, instead you use natural log. So we're going to take the natural log of both sides, and these undo each other. You just have 2x equals ln of 5, and then go ahead and divide out the 2. I'm going to write it as a 1/2 in front. Again, dividing by 2 is the same as timesing by 1/2, so 1/2 ln of 5, and you can just leave your answer like that. Finally, we're going to solve log equations. You can obviously see that you have logs in your equation. And we're going to use a couple of different techniques. So for this first example, log base 3 of x plus log base 3 of x plus 1 equals log base 3 of 2. The first thing we're going to do is we're going to use properties of logs on the left side and condense. So this would condense to log base 3 of, and we're going to take, because of the plus, and they're both positive, we're going to take these and multiply x times the quantity x plus 1. So you get x squared plus x, and then drop down the log base 3 of 2 on the right side. All right, so at this point, you have an equation. They both say on both sides log base 3 of, so you can use the logic that since these are equal and they're the same log base 3, that you can then set the insides equal. So we'll go x squared plus x equals 2. And now you have a nice quadratic equation. So let's subtract that 2 over, set the quadratic equation equal to 0, and factor this. So we get x and x. 2 times 1 is 2. Let's go positive, negative, and all right. So applying the zero product property, you're going to set both of these equal to 0, and what happens is you get negative 2 and positive 1. The important thing about answers that you get with log equations is you have to make sure that the values work with the original problem, and the big thing to be cautious about is you cannot take the log of a negative number and you can't take the log of 0. So if we plug in negative 2 right away, you can see you're going to take log base 3 of negative 2, so that can't happen. So that's not going to be a valid answer. So let's check the other value, 1. Log base 3 of 1 plus log base 3 of, when you plug in 1, you get 2, question mark, and you get log base 3 of 2. So on this left side, plus means you're going to multiply these, and you get log base 3 of 1 times 2 is 2. And it checks out. You get a true statement, and you're okay with taking the log of positive 1 and the log of positive 2. So we're good. So the final answer is just x equals 1. Okay, this example says log of 2x plus log of the quantity x minus 5 equals 2. We're going to treat it the same way we did with the last problem at first. So first step is we're going to condense this left side. They're both positive logs, so we're going to condense using a product. So we'll go log of, and we'll go 2x times x minus 5, so make sure you distribute. So you get 2x squared minus 10x. There's no base, it's implied base 10. So log base 10 of this quantity equals 2. We're trying to solve for x, and it's buried inside of the log. So what we're going to do is we're going to do a process called exponentiate. So we're going to exponentiate this log equation. What you do is you identify where the variable is, and then you look at the base number on that log. So the base number is 10. So to exponentiate, it's really strange. You take 10 and you move both sides of the equation into the exponent. At this point, because this is technically a base 10 right there, these are going to undo each other, and you're left with 2x squared minus 10x equals, then over here you get 100. All right, so now you have an equation. Let's divide by 2 to the entire equation. At this point, let's subtract the 50 over. And it should factor, I hope. So let's use 10 times 5 is 50, negative and a positive, and that should work out great. So zero product property, you get x equals 10 and negative 5. We kind of talked about this. Double check your answers with logs. Then negative 5, if you plug it in right here, you get log of negative 10, and you can't take the log of a negative, so that gets rid of that option. And then you have 10, so we'll check 10. So you get log of 20. Plug in 10, so that would be log of 5 equals 2. That's a question mark. And then finally we'll condense this, so you get log and then 2 times 5, or 100, question mark equals 2, and then finally over here, base 10, 10 to the what power is 100, and thank goodness it's 2. So we get 2 equals 2, it checks out, so our answer is x equals 10. We have log base 4 of the quantity 5x minus 1 equals 3. And you have a log on the left and no log on the right. So this is a log equation, and you're going to use the process of exponentiating again. So you identify where the variable is, you look at the log, and then you look at the base number. So the base number is 4. So we're going to exponentiate with base 4. So we'll go 4, 4, and what you do is you take both sides and you put them in the exponent. Again, it seems so strange at first. Then you get used to it. On the left side, you have 4 to the log base 4. They undo each other, and you get 5x minus 1. Over here, 4 cubed is 64. And finally, you get 5x, add the 1 is 65. So we get 13. And remember, log equations, always just double check the number that you get. Plug it in. 5 times 13 was 65. 65 minus 1 is 64. And 4 to the third power is 64, so it works. X equals 13 is our answer. Here we have 6 times natural log of 4x equals 15. So like a normal equation, let's divide out that 6. And any fractions you can reduce, go ahead and do so. So we'll divide by 3, so we get 5 over 2. All right. So you have a log on one side and you have a number on the other, so we're going to use that process, exponentiating again. You find the variable, you look at its log, technically that's log, specifically with base e. So e will be the base we use to exponentiate. So you do e on both sides, and then you raise both sides of the equation into the exponent. So ln of 4x and 5 halves. All right, e to the ln. Because ln is really log base e, they're going to undo each other, and you just have 4x equals e to the 5 halves. And very last step, divide out the 4. So I'm going to write it right there. 1/4 e to the 5 halves.